So the topic for today is decision tree and hyperparameters, modeling using decision tree and hyperparameters. We have done some brief study about decision tree and how, in fact, we had a war of words, myself and Sharath especially, about why decision tree is, the most, what shall I say? Excuse me. Not recognized, or the really strong one, but doesn't get its due, what it should get among the various models. Everybody runs towards neural networks and things like that, and they say, "Yay, neural networks is great." But the decision tree also is a real hard worker, a workhorse, but doesn't get the due credit what it should do. So we'll try to give it some credit. So Sharath, could you just start off by telling me about the generic interview question could be like, why is decision tree chosen as a modeling? On what basis do you choose decision tree? Could you just throw some light on that?
Yes, Nitin. Good evening. Good evening, everyone. And again, as usual, welcome back to the channel, and very happy to see you all. Hope you're taking the advantage, right? So that is more important, and hope you are noting down all the discussion points that we are having here. Coming to the topic, decision tree is one of the very, very fancy algorithm, I would say, because of all the noise it makes for good reasons or bad reasons. And like Nitin said, the decision tree does not get the due weightage that it should receive. But it becomes one of those very important base ingredients which actually forms or allows us to form very complex algorithms. But of course, it's a vanilla model, the basic model, and it runs on rules. And because of these rules, decision tree becomes one of those very, very important algorithms which can be used for explainable scenarios. And decision trees are heavily used in sectors like banking, where there is very, very high importance given to the explanation of your results. So decision tree gives us classification rules, the path, the sequence steps. And thanks to this information, we will be able to interpret the results. But the decision tree also has the problem. Because of this specific problem, it does not get its due diligence, due importance. And that problem is overfitting problem. Among all the algorithms that we talk about in predictive analytics models, decision tree is the model which is most prone to overfit. The algorithm is designed in such a way that it generates rules on all the records of your training data set. So it tries to force fit each and every record from your training data. And when that happens, when you're trying to fit in, or when you're trying to predict the results on the same training data set, you would get appropriate result thanks to the force fit design of the algorithm. So you're going to get 100% accuracy on your training data set. But when you use those rules to try and predict on your test data set or validation data set, you may not get the exact result that you seek. So it fails to give you the right predictions on test data set or validation data set. And this is where you see overfitting problem. Now, when do you choose? I've already mentioned, wherever you need to have the explanation done for your models, we always rely on these explainable models, and most preferred is decision tree. And the another advantage that decision tree also gives us is the list of hyperparameters that it contains. Whenever you want to tune your algorithm, whenever you want to fine tune it and improve the performance, every algorithm has a bunch of parameters, which everybody knows here, right? So you all know about it. But decision tree is one of those algorithms which has a huge list of parameters, right? So that is the reason why the decision trees are also preferred But again, the drawback is still there. Hence, it doesn't get its due importance.
Thank you, Sharat. I